Welcome back. Okay, so for today's explainer, we are jumping right into a mind-bending, cosmic thought experiment that's going to challenge literally everything you take for granted about our place in the universe. Imagine, just for a moment, that the absolute main engine of our solar system was suddenly just gone.
What if the sun simply vanished without a trace? And I don't mean it explodes in a massive fiery supernova or, slowly burns out into a brown dwarf over billions of years. I want you to imagine that our star is completely deleted from the universe. It's almost as if somebody reached out into the very fabric of reality and hit the backspace key on a cosmic computer file. Poof, gone. So what exactly would happen to us? What would the next chaotic minutes, days, and years actually look like for Earth and everyone on it?
8 minutes and 20 seconds. Well, immediately after the sun vanishes, absolutely nothing happens. Seriously, we would get a precise grace period of glorious ignorance lasting exactly 8 minutes and 20 seconds. For that entire time, the sky would look completely normal. People would still be walking their dogs, grabbing their morning coffee, sitting in traffic, completely oblivious that the 864,000-mile-wide star holding our entire solar system together had just vanished into thin air.
Light travels at a universal speed limit of 186,000 miles per second. So this whole illusion happens because of the massive 93 million mile gap between Earth and the Sun, combined with the universe's ultimate speed limit. Light travels at that astonishing 186,000 miles per second, but even at that blistering speed, it still takes time to commute. The last photons emitted by the sun right before it vanished would still take over 8 minutes to cross all that immense empty space to reach our eyes. So for those final minutes, we'd literally just be looking at a ghost.
Now let's compare Newtonian gravity to Einstein's general relativity. Newtonian model predicts an instant loss of orbit, while Einstein says gravity ripples through space-time at the speed of light. And this actually brilliantly illustrates one of the most fascinating discoveries in physics. You see, if Isaac Newton's theory of gravity were right, the loss of gravitational pull would be instantaneous. That means we'd instantly fly off into space while still seeing the sun up in the sky. But Albert Einstein's general relativity showed us that gravity isn't just some invisible tether. It's a bending of space-time that ripples outward at the exact same speed as light. So our gravitational loss wouldn't be instant either. It means that, amazingly, Earth's orbit remains totally secure for those exact same 8 minutes and 20 seconds.
Part 1. The breakaway, rogue planet Earth.
Earth breaks its orbit, no longer anchored by a star 333,000 times its mass. So the very second that 8-minute and 20-second grace period is up, the sky goes pitch black, and simultaneously, the gravitational tether snaps. Without the sun holding us in a tight, circular orbit, our planet instantly obeys Newton's first law of motion. We break our orbit and we shoot off in a perfectly straight line into the dark void. 67,000 miles per hour. That is how fast we'd be moving. Earth instantly transforms into what scientists call a rogue planet. Our carefully choreographed cosmic dance is totally over, replaced by an uncontrolled careen into the unknown depths of the Milky Way at a staggering speed of 67,000 miles per hour. Imagine sitting in your living room right now, completely unbothered, while the very planet beneath your feet has just become a detached spaceship rocketing blindly into the interstellar vacuum.
Section 2. The Deep Global Freeze.
1 week, 0 degrees Fahrenheit. 1 year, negative 100 degrees. Millions of years, negative 400 degrees Fahrenheit. While we're out there speeding into the darkness, we have to face a chilling new reality. Without our external heat source, the global plunge begins almost immediately. Now, Earth doesn't freeze solid the very first second because it takes time to radiate our existing heat out into space. Think of it kind of like turning off an oven, right? It stays warm for a little while. But within just 1 week, the average global surface temperature plummets to 0 degrees Fahrenheit. Fast forward 1 year, and we hit negative 100 degrees. And eventually, over millions of years, the planet settles at around negative 400 degrees Fahrenheit, stabilized only by the faint heat radiating from Earth's own core.
The biospheres collapse. Photosynthesis halts instantly. Most plants die in weeks, large trees survive for decades, herbivores starve, and scavengers eventually freeze. Way before we hit those ultimate deep freeze temperatures, we witnessed the rapid sequential collapse of the food chain. The tragic irony here is that without photons, the entire engine of life on the surface, photosynthesis, just stops immediately. Most plants die within weeks. Now sure, some massive trees with huge sugar stores might technically survive for decades, but they wouldn't have anyone around to appreciate them. The bottom of the food chain gets knocked out entirely. Herbivores starve quickly, and the scavengers picking over their frozen remains would really only last until the extreme cold finally claimed them too. At negative 400 degrees Fahrenheit, the atmosphere collapses, raining down as snow made of solid nitrogen and oxygen. Now, maybe the most terrifying sensory visual of this whole scenario happens as we approach that negative 400-degree mark. It gets so unbelievably cold that the very gases we breathe literally freeze. The entire atmosphere would collapse, falling to the barren surface as actual snow made of solid nitrogen and oxygen. Just picture that for a second. The sky itself turning into a solid blizzard, leaving Earth as a completely frozen, airless ball drifting quietly through space.
Part 3. Surviving the Deep Dark. The oceans freeze from the top down, with surface ice insulating the deep liquid water for hundreds of thousands of years. I know, this all sounds like pure cosmic doom, but let's pivot for a moment and look at human ingenuity. Is there any glimmer of hope for our species in this dark, frozen reality? Well, interestingly enough, water has a very unique property. Ice floats, so the oceans would actually freeze from the top down. That thick layer of surface ice would act as an incredible blanket, insulating the deep liquid water below. This means liquid oceans could persist for hundreds of thousands of years, which offers a potential, albeit incredibly bleak, habitat for humanity if we could somehow establish ourselves in high-tech deep-sea submarines.
Enhanced Geothermal Systems, or EGS. This means using high-pressure fluid to extract Earth's internal radioactive heat for energy. Now, what's really interesting about this is our other major option for survival requires looking way, way down. The Earth's core remains incredibly hot due to radioactive decay and leftover heat from when the planet formed. This internal heat isn't going anywhere. Through enhanced geothermal systems, we actually have a viable, completely sun-independent power source right beneath our feet.
87 degrees Fahrenheit. And here's the kicker, you wouldn't even have to drill all the way to the core to feel it. For literally every single mile you drill down into the Earth's crust, the temperature bumps up by roughly 87 degrees Fahrenheit. This makes deep subterranean bunkers a massive opportunity. If we dug deep enough, we could theoretically build vast, interconnected city habitats that stay warm naturally. Picture generations of humans living miles underground, using that geothermal heat to power artificial lights, grow hydroponic food, and run advanced closed-loop life support systems, all while the surface remains a total frozen wasteland.
Iceland already heats 87% of its homes using geothermal energy. So the crucial point here is that we already have the blueprint for this kind of survival. We wouldn't have to invent the concept from scratch. Nations like Iceland already heat the vast majority of their homes using this exact geothermal energy. In a sunless world, places with high volcanic and geothermal activity would become humanity's absolute last sanctuaries, allowing small, well-prepared pockets of humans to potentially survive for centuries in the dark.
Section 4. The Ultimate Deep-Sea Survivors.
Microscopic extremophiles clustered around deep-sea geothermal vents already live in total darkness. Because honestly, even if a few really lucky humans managed to cling to life in those deep underground bunkers, they wouldn't be the true rulers of this rogue planet. Far, far below the frozen surface of the ocean, clustered around deep-sea geothermal vents, there are thriving ecosystems of microscopic extremophiles, bacteria and tubeworms that already live their entire lives in total absolute darkness. If the sun vanished today, these creatures literally wouldn't even notice. Their day-to-day lives wouldn't change one single bit.
Powered by the Earth's core, these deep-sea bacteria will outlive humanity by billions of years. Because these little guys are completely powered by the chemical energy of the Earth's core rather than sunlight, they are perfectly suited for our rogue planet. And this is really the profound irony of our explainer today. For all the fragility of complex human civilization, the sheer, unyielding resilience of extremophile biology means that life on Earth wouldn't actually end. These tiny, incredible organisms will just continue to thrive in the pitch black, outliving humanity by billions of years as Earth sails endlessly through the void. What cosmic disasters should we explore next? This whole explainer really strips away our assumptions about how permanent we are, doesn't it? We are incredibly lucky to have that bright star keeping us warm and keeping us perfectly in orbit. So, what do you think? What cosmic disaster should we explore next? What other universal what-ifs keep you up at night? Let me know in the comments, hit that subscribe button, and let's keep exploring the incredible science of the extreme together.